Today's lesson, section 3.6a, complex zeros and the fundamental theorem of algebra, will be finding all the zeros of a given polynomial when our answers are complex numbers. So I'm going to use my rational root, or my rational zeros theorem. So my q is 1 and my p is 18. So then 18, 9, 6, 3, 2, and 1, and then I just have a factor of 1 at the bottom. So then making my combinations, it'd be 18, 9, 6, 3, 2, and 1 with plus or minuses. Okay, and so there's my list. Now also I want to use Descartes' rule of signs to help me out. So for the positives, there are no changes because you go from positive, 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 positive. Okay, so there's 0 positive values. So that makes it easy. You just cut out half of your answers or possible answers from that, so you can get rid of all the positive ones because none of them are going to be right. Now I want to look at the negatives. So then, looking at that, that would give me negative x cubed plus 7x squared minus 18x plus 18. So now it looks like I have 1 change, 2 changes, and 3 changes. Okay, so there are 3 at most negative solutions. So all of my answers could be negative real numbers, or another combination would be as if I had 2 complex numbers and 1 negative. But that tells me at least of one of my answers needs to be a negative value. That's not imaginary. So now we need to just set up our synthetic division. So I get 1, 7, 18, and 18. Okay, so here we need to choose a value. Let's choose negative 3. So add down 1, multiply gets me negative 3, add down gets me 4, multiply gets me negative 12, add down gets me 6, multiply gets me negative 18, and adding down gets me 0. So this must be a 0 for my solution. So I found one. Now let's recreate this equation from the bottom after it's been divided out. So I get x squared plus 4x plus 6. Now looking at this one looks like it doesn't factor actually, because it would be factors of 6 that add up to 4, and there are no factors of 6 that add up to 4. So I need to go to my quadratic formula. So then negative 4 plus or minus 4 squared minus 4 times 1 times 6, and then 2 times 1. So now I can simplify a little bit. Inside the radical, I get 16 minus 24, and then 16 minus 24 is negative 8. And then, because there's a negative inside the radical, that means there must be a complex number in there, so imaginary. So when I do a square root of 8, it reduces to 2 square root of 2, but then take out the negative, it would be 2i square root of 2, divided by 2. Each term has a 2 involved, so I can reduce all of them by 2. So that means that I get negative 2 plus or minus I square root of 2. Remember, the radical inside that does not reduce. So my zeros for this polynomial would be negative 3, which we found previously, and negative 2 plus or minus I square root of 2. And that would be my answer. Have fun.